Hello everyone. So today let's solve the problem number 127 word ladder. So let's see what the question states here. So we have to find the length, nothing but the number of words, right? So we have to find the length, nothing but the number of words here of the shortest transformation sequence from begin word to end word. From begin word to end word, sorry. From begin word to end word. Shortest, what we need to find? We need to find the length of the shortest transformation sequence from begin word to end word, where each step changes exactly one letter, where each step changes exactly one letter. Either a H can be changed, this one a H can be changed, I can be changed, or T can be changed. Exactly one letter and one step at a time. Yeah, exactly one letter, and every intermediate word must be in the word list. This one, yeah, every intermediate word means so whatever the word that we change, that word has to be in the this one. What do we call word list, right? Whatever the letter that we change. So this one, suppose I change this one H, this one I to O actually. Just for the example sake, I change I to O, it will be hot, right? And hot is present in the word list here. So that's what they have given. So every intermediate word must be in the word list. We have to return 0 if no such sequence exists. If no such sequence exists, then we have to return 0. That's what they have given in the question. And words have the same length and are lowercase. Words are of the same length and are lowercase they have given, right? So this is fine. Next, let's do one thing. Let's go with the explanation part here. See, we have begin word hit, we have end word cog, right? So the this one word list that we have here is hot, dog, sorry, dot, dog, lot, a log, and cog actually. Yep. So see here, from this one of the shortest transformation sequences, first one we have the word hit, begin word, right? Then we will change I to O, one letter at a time, right? So this one we will change. Just give me a second here. 1 second. Yeah, we will change this one to O actually. Then what it becomes? It becomes hot, right? So then from hot, so this one from H we will change this one to letter D. So this is fine. Dot, right? So hot is present, dot is also present, right? So next what we will do? We will change the T to this one G actually. Then it becomes dog. Dog is in the this one. What do we call? Word list actually. Then from the dog, we can directly we can just ignore these two actually. What do we call? Lot as well as the log. We can directly go with the cog because see, changing one letter would lead to cog here, right? Changing D from C actually, D to C actually, right? So we will get cog actually from this one. First word was hit actually, hit. So this is one, two, sorry, one, two, three, four, five. Total sequence that we have here is five, right? So one thing, we have to find the length of the shortest transformation sequence, right? So overall length is 5 here. You can clearly see hit, hot, dog, dot, dog, as well as the cog. So total length is 5 here. This length we have to, this one, what do we call? Output, right? So here, this one, the output that we got here is 5, which is equivalent to the output they have mentioned here, right? So this is fine. Yep, the next one is we have the begin word hit and end word cog, but the word list we have is this one. What do we call? Hot dot dog lot log, right? So here in this case, it is not possible. We can change this one to hot. This is fine. From hot, we can change this one to dot. This is also fine. Dot to basically see this one hit. We will change this one to hot. This is fine. I to O actually. Then we will change this one H to D, that becomes dot. Then we will go with a dog actually. This is also fine. And even from the dog, uh, we cannot go with this one. We can go with the log actually. We can change this one to the log. But in the word list, we have not been given cog at all. This word itself is not in the word list actually, right? So this word is not in the word list at all. So however ways you try to change, you can keep changing on this one actually, a single letter, but it will never lead to the cog, the word cog. So in this case, we have to return 0, right? In this case, we have to return 0, right? So this is fine, I believe. So let me delete this one. Let's do one thing. Let's do one thing. Now, mm, we have the understanding of the question. They have given us wonderful examples as well. Let's do one thing. Let's discuss the approach followed by the complexities, and then let's write the code. So before hopping into the approach, let me tell you one thing. So we will be going with a let's go with a BFS. Previous problem we solved with a DFS, I believe. So let's go with a BFS to solve this particular problem. Yeah. So first thing, let's discuss the approach here. First, what we will do here, first step. So we will pre-process words into intermediate patterns by replacing one letters, nothing but this one. So first it will be hot, then it will be like we will be going with the OT. So we will be replacing H actually. Then we will be replacing this one O. This will be, I can just write it in this way. Whatever the letters that I'm replacing, I'm writing that one with a X actually, right? So this is fine. Then finally this one, yeah. So this is fine. Yep. So we will build the map pattern. We'll build the map pattern list of words that is sharing that particular pattern, right? So this is the first step. Then what we'll do, we'll treat each word as a graph node. Then we'll treat each word, right? So whatever the word that we are changing into, then we'll treat each word starting from the, suppose if we consider first example itself, we'll treat each word. So starting from the hit, next we are changing this one to hot, this one, dot, dog, as well as the finally cog, right? So this one, each word we are treating this one as the graph node actually. Two nodes connect if they share a pattern, right? Differ by only one letter. So this we can just represent in this way. First, hit. So we'll just consider this one node. Then hit is connected by the hot actually. Yeah, one this one. This is one node. So we can just go with undirected graph. Yeah. Next, hot to dot actually. Yep, hot to dot. Dot to this one, dot to dog actually. So this is one node, dog is one node. Finally dog is connected to cog actually. So this is also one thing. I'll just go with the dog here, right? So this is fine, I believe. If they connect the share this one, two nodes connect if they share a pattern, right? So differ by one letter. Then what we'll do, we'll run the BFS from the begin word. We'll run the BFS from the begin word. Yeah. BFS, what it does, it ensures the first time we reach the end word is the shortest path. Here in this case, we'll reach the cog, right? So when we reach the this one, sorry, this is not dog actually, cog, COG. When we reach the cog actually, this is the last level, right? So suppose if we have considered this one graph, so this is the first level, so this is the second level, and this is the third level. And when we reach this level, and when we have this one reached this one COG actually, third level, so basically BFS stops here, right? BFS stops here. BFS ensures the first time we reach the end word is the shortest path actually, shortest path. So this one will be one, it will be counted in this way, 1, 2, 3, 4, 5. So starting from the hit one, so this one, 2, 3, 4, 5. Actually, we have to consider in this way. Hit one, a hot two, this one dot is level 3. So I should have written in this way, down dot here, down to the dot, I should have written dog, and finally this one, cog actually. Each is of the one level actually. This is second level, this is third level, this is fourth level, and this is fifth level. Sorry, I have mentioned 1, 2, 3, right? So here, let me remove this 3 actually. Yeah, this is level 1 actually. This is level 2. Remove this one entirely in this way actually. Right, so this will be dot, dog, and finally the fifth one, cog, right? So this one. So we apply BFS here. 1, 2, 3, 4, and 5. So level 5, right? So this level we will be returning this one as the output. Right? I hope this is clear, man. Yep. So the output that we got here is cog, which is equivalent to the output that they have mentioned for the example one within the question, right? So here, what we will do first, accordingly with how we will apply the BFS, I'll just show you. First, what we'll do, we'll go with the hit actually. This is level 1. So neighbors from the patterns is nothing but hot. We have the hot here, right? So hot, we will NQ hot actually, which is level 2. We will NQ hot, which is level 2. So this is fine. Next, for the hot, we have neighbors. So we'll enqueue this one. For hot, we have the neighbors actually hit dot and lot. Hit dot and lot, right? So this one will check all the things right here within the word list actually. Hit dot and lot. Right? So this one, these three, right? So this is fine. So we will enqueue unseen dot, right? Dot. Next we'll go with a lot, right? So this one either we can go with a dot or we can just go with a lot. Either of them works, right? So we will enqueue dot and lot. So let's go with the dot itself, yeah. So this is fine. Next, what we will do, we'll this one. What do we call? We'll dequeue dot actually. We'll dequeue dot here. So we'll dequeue not NQ here. We'll DQ, sorry, I got confused here. We'll DQ dot neighbors include dog, right? So after DQing dot actually, what we'll do, neighbors include this one dog actually. We'll NQ dog. We'll NQ dog, right? So this is fine. NQ dot. So we'll DQ dot. Yeah, we'll be NQing actually. This is correct actually. So we'll again DQ dot, but NQ dog here. This is fine. Next, what we'll do, we'll DQ dog. This time we'll DQ dog. This is fine. We'll DQ dog. Neighbors include cog. Neighbors include here cog, right? So we will NQ cog. We will NQ cog, right? So we'll NQ or add cog. So found, we have successfully found the end word, right? So at the level 5. So we will return this one level 5 as the output, right? So this one, the output that we got here is 5, which is equivalent to the output that I have mentioned for the example 1 within the question, right? As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. Let's quickly discuss the complexities part. Now, what will be the time complexity here? The time complexity would lead to big of m into n, right? So I can just write it on this way, big of m into n. Because see, n is nothing but the number of words, word list size plus begin word, right? And m is nothing but this one, word length, right? So constructing patterns and traversing each pattern's neighbor list overall visits it roughly once here. So overall time complexity would lead to big of m into n. So what will be the space complexity? You would have already guessed. It will be m into n as well. So why it will be m into n? Easy. So we will be going with the pattern map and the BFS or the visited structure, right? So overall space complexity would lead to big of m into n. So we'll be purely going with the BFS to solve this particular problem. With BFS, we can solve this particular problem easily, man. That is the reason we'll be going with the BFS in simple terms. Yeah. So now, as we are completely familiar with the approach as well as the complexities, we are good to write the code. Let's start writing the code. So suppose if the end word is not in the dictionary, no transformation is possible, right? So let me go with if condition here. So let me go with word list. Let me copy this one and paste it over here. Dot contains. So let me pass the end word. There is end word. So let me copy this one and this one end word. We have to return 0 in that case. Yep. So if the end word is not in the dictionary at all, no transformation is possible. In that case, we have to return 0. They have strictly mentioned that one in the question. Yep. So this is one of the edge cases. So all the words, right, have the same length. All the words have the same length that they have mentioned in the question. So I'll just give here L equals, let me go with the begin word here. Begin word dot length. Yep, so this is fine. The next step would be we have to build the map for the intermediate pattern to the list of the words having the pattern, right? Example pattern I showed. For the heart, when I equals 0, it will be star OT. So I mentioned in X, right? So when I equals 1, it will be H, this one star T. For I equals to 2, it will be H O star, like that. It goes on, right? So I'll just go with the map here. Map of string. This is fine. Map of string. Let me go with list of string. List of string. So what is the variable name? Let me go with a pattern map here. So this is fine. New hash map. Yep. So next, let's do one thing. Let's include all the word list. This one words in the pattern map. So let's go with the two for loops here in simple terms. For string word list. So this is fine. Let me go with one more for loop. So this one will be int I equals 0, I less than L I plus plus. So within the for loop, let me go with pattern, string pattern. I'll just go with small p here. Anyways, let me assign this one to word dot substring here. This is fine. Substring of 0 comma I. Yep. So this one will be. Let me go with the star here. Word dot again substring. So let me make use of this one again. Let me paste it over here. So the next word I plus one. Yeah. So this is fine. So now we have to get list this one for the pattern, or we have to create new, right? So I'll just go with the pattern map here. Where did I give pattern map? So this one, let me copy this one. Let me paste it over here. Dot compute if absent. I'll be making use of the compute if absent here, provided by the hash map. So let me go with pattern. Okay, go with lambda here. New array list. So this is fine. Let me complete the syntax. So I'll just go with add of what we need to add here, individual word, right? So add of word. So this is fine. Let me come out of this one entirely. Now what we need to do, if it's possible, begin word is not in word list, then also we have to add its patterns to allow the edges, right? So to allow the edges from where? From the this one. What do we call? Begin word actually. Yep. Let's write the simple for loop for it. So I'll just go with for int I equals 0, I less than L, I plus plus. So within the for loop, let me go with string pattern. Give the small p here. So this is fine. Let me assign this one to begin word. Copy this one, paste it over here. Dot substring. So I'll just copy this one and paste it over here. So this is fine. Yep. Next substring of 0 to I actually. Yep. Then we have to append. Let me append the star here. So we have already discussed this pattern, right? So I'll just go with again begin word dot substring. So let me copy this one over here, paste it over here. Again, it has to be I plus one, right? So we have the idea on this. Yep. Next, again, what we have to do? Let's go with a pattern map here, right? So let me copy the same thing here and let me paste it over here. Pattern map dot compute if absent. So this one will be pattern comma k to new array list, right? So we don't have to add word here. We don't have to add any word here. So this is it actually. Yep, let me come out of this one entirely. Now let's go with a BFS. Let's go with a BFS, right? So BFS uses queue. Actually, let's go with a BFS queue. Now, I'll just go with queue here, where within the angle brackets, give pair here. So this is fine. Q equals new linked list. This is fine. Yeah. The next one is, let me go with a Q dot add of this one, new pair of let me go with a begin word here. Let me copy this one. Let me paste it over here, comma 1. Yes. Now let's do one thing. Let's go with a visited set to prevent the this one revisiting words. So let me go with set here. Set let me go with string, set string. I'll just go with visited equals new hash set. So this has to be capital, right? So this is fine. Let me complete the syntax here. Also, let me add the this one begin word to the visited, already visited, right? So let me paste it over here. Begin word. Yep. So this is fine. The next thing, let's go with the standardized BFS loop here. So while not of q dot is empty. So then, so within the while loop, let me go with where current equals q dot poll. So this is fine. The next thing would be I'll just go with the string here. Word equals dot word. So this is also fine. The next one is int level equals current dot level. Yep. So this is also fine. Next, what we'll be doing here for the current word, we have to iterate all the intermediate patterns to find the neighbors. So let me go with the for loop here. Int I equals 0, I less than L. So let me increment the I here. So here, within the for loop, let's do one thing. I'll just go with the pattern of the type string. So this one will be word, but substring. So substring somewhere we have used, right? So I'll just copy this one and let me paste it over here. Again, the same thing from 0 to I, and also me copy paste this one. Begin word dot substring. Instead of the begin word, I'll just go with the word actually here. Just go with star plus word dot substring of I plus 1. So this is fine. Yeah. The next step would be for each neighbor, uh, we have to share this pattern, right? So I'll just do one thing. 1 second. Yeah. For each neighbor, let's share this pattern. So I'll just go with the list here. Let me go with the string neighbors equals, let me go with the pattern map. Where did I use the pattern map? Let me copy this one somewhere. Yep. So this is fine. Pattern map dot, I'll just make use of the get or default that is provided by the hash map. So this is fine. Within the get or default, let me pass the pattern. Along with the pattern, I'll just go with the this one collections dot empty list. Yeah, collections dot empty list. Yep, this is also fine. Next, let's move on with the for loop for string neighbor of neighbors. So this is fine. Within the for loop, if found end word, then we have to return level plus one, meaning we have to include the neighbor, right? So I'll just go with if of, let me copy this one neighbor, if of neighbor dot equals of, let me go with end word actually, right? So end word, so this is fine, end word. So then let me return here level plus one, level plus 1. Yeah, let me come out of this one entirely. If not visited, then we have to mark an NQ, right? So I'll just go with if not visited uh, dot contains of neighbor. So I'll just copy this one. Let me paste it over here. Then let me go with visited here dot add of, again let me pass the neighbor here. Finally, we have to go with a q dot add. What we need to add here, new where of, let me pass the neighbor here. Along with the neighbor, this one we have to move to the next level, right? So I'll just go with level plus 1. Yep. So this is fine. Let me come out of this one entirely. So this is the optional optimization here. We are just or we can just clear the neighbors list to prevent the redundant future checks actually. This prevents revisiting the same pattern many times. You can go or you can avoid this one. I'll just go with it, right? So I'll just go with pattern map dot put. So this one is fine. Pattern comma new array list. Yep, new array list. So this is fine. Let me come out of this one entirely. Now, if BFS completes without finding the end word, then we have to return 0 in that case. So I'll just give return 0. So let me come out of this one entirely. Let's go with a small helper pair class just to hold the word and BFS level, right? So I'll just go with the private static class pair, right? So this is fine. So within the helper method pair, so I'll just go with here string word. So this is fine. Just go with int level. Yep, so this is also fine. Let me go with pair string w int l. Uh, this is fine, man. So I'll just go with word equals w level. Let me set this one to the level. Let me set this one to the L actually. Let me format the code and let me hit the run button. So this is it for the code actually. Yep, I hope this works. We have invalid method declaration pair. So this has to be capital P actually, I believe. Yeah. So now this has to work in my opinion. Let's check. Let me run this one. We have went with a capital P actually. So this one level I have misspelled here, line number 43. Yeah, the run button. At least now this has to work. Let's see. Yeah, the sample test cases are getting passed. So let me hit the submit button quickly. Yeah, we have discussed this one, or we went step by step actually, right? So this is fine. So you can clearly see here, all the test cases are getting passed, meaning whatever the code that we have written works absolutely correct for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.